Machine learning is a complex discipline, but implementing machine learning models is far less daunting and difficult than it used to be, thanks to machine learning frameworks such as Google's TensorFlow that ease the process of acquiring data, training models, solving predictions, and refining future results. Created by the Google Brain team, TensorFlow is an open source library for numerical computation and large scale machine learning. TensorFlow bundles together a slew of machine learning and deep learning models and algorithms and make them useful by way of common metaphor. Google uses machine learning in all of its products to improve the search engine, the translation, image captioning, or the recommendations. To give you a concrete example, Google users can experience a faster and more refined search with artificial intelligence. If the user types a keyword in the search bar, Google provides a recommendation about what could be the next word. Now, TensorFlow is being used by a lot of companies in the industries, and to name a few, first let's start with Airbnb, the leading global online marketplace and hospitality service. The Airbnb engineers and data science team applies machine learning using TensorFlow to classify the images and detect objects at scale, helping to improve the guest experience. And if we talk about the healthcare industry, using TensorFlow, GE Healthcare is training a neural network to identify specific anatomy during the brain MRI exam to help improve speed and reliability. Now, PayPal is using TensorFlow to stay at the cutting edge of fraud detection. Using TensorFlow, deep transfer learning, and generative modeling, PayPal has been able to recognize complex fraud patterns to increase fraud decline accuracy while improving the experience of legitimate users through increased precision in identification. China Mobile is using TensorFlow to improve their success rate of the network element cutovers. China Mobile has created a deep learning system using TensorFlow that can automatically predict the cutover time window, verify log operations, and detect network anomalies. And this has already successfully supported the world's largest relocation of hundreds of millions IoT HSS. Now, let's talk about the TensorFlow feature, what makes it stand out from the other competition. So TensorFlow offers multiple level of abstractions so you can choose the right one for your needs. You can build and train models by using the high-level Keras API, which makes getting started with TensorFlow and machine learning very easy. If you need more flexibility, eager execution allows for immediate iteration and intuitive debugging. When you enable eager execution, you will be executing TensorFlow kernels immediately, rather than constructing graphs that will be executed later. Now, it provides a direct path to protection, whether it's on servers, the edge devices, or the web. TensorFlow lets you train and deploy your model easily, no matter what language or the platform you are using. You can build and train the state-of-the-art models without sacrificing speed or performance. TensorFlow gives you the flexibility and the control with features like Keras functional API and model subclassing API for creation of complex topologies. TensorFlow also supports an ecosystem of powerful add-on libraries and models to experiment with. Now, TensorFlow's name directly derived from its core framework. In TensorFlow, all the computation involves tensor. So, a tensor is a vector or a matrix of n dimensions that represents all the data type. All the operations are conducted inside a graph, and the graph is set of a computation that takes place successively. Each operation is called an OP node and are connected to each other. TensorFlow allows the developers to create data flow graphs, which are structures that describe how the data move through a graph or a series of processing nodes. Each node in the graph represents a mathematical operation, and each connection or edge between the nodes is a multidimensional data array or tensor. TensorFlow provides all of this for the programmer by way of the Python language. Python is easy to learn and work with and provides convenient ways to express how high-level abstraction can be coupled together. Nodes and the tensor in the TensorFlow are Python objects, and TensorFlow applications are themselves Python applications. Now, the actual math operations, however, are not performed in Python. The libraries of transformation that are available through TensorFlow are written as high-performance C++ binaries. Python just directs the traffic between the pieces and provides high-level programming abstraction to hook them together. Now, building a neural network cannot get any more simpler. Usually, any machine learning or deep learning process has some similar steps, but in this case of TensorFlow, it is so simple. Any typical machine learning lifecycle or any process has some of these steps like collection of data set, then building the model, training the network, evaluating the model, and then predicting the outcome. In case of TensorFlow, most of the time is occupied in the collection of data set. Now building your model requires only a few lines of code. Training the network is just a single line. Evaluating the network or the model itself is a single line of code, and predicting the model is also a single line of code. Now, training a neural network cannot get any more easier than this. And that is why TensorFlow remains at the top when compared to the other competitors. Now, TensorFlow competes with a slew of other machine learning frameworks like PyTorch, CNTK, and MNNext. These are the three major frameworks that address many of the same needs. Now, PyTorch, in addition to being built in Python and has many other similarities to TensorFlow, the hardware accelerated components under the hood, a highly interactive development model that allows for designing as you go work, and many useful components are already included. Now, PyTorch is generally a better choice for fast development of projects that need to be up and running in a short time, but TensorFlow wins out for larger projects and more complex workflows. CNTK, the Microsoft Cognitive Toolkit, like TensorFlow, uses a graph structure to describe the data flow, but it focuses more on creating deep learning neural network. CNTK handles many neural network jobs faster and has a broader set of APIs for Python, C++, C Sharp, and Java, but CNTK isn't currently as easy to learn or deploy as TensorFlow. Now talking about Apache MXNet adopted by Amazon as a premier deep learning framework on AWS can scale almost linearly across multiple GPUs and multiple machines. It also supports a broad range of languages API like Python, C++, Scala, R, JavaScript, Julia, Perl, and Go. Although its native API aren't as pleasant to work with as TensorFlow, it is also in the market. Now, the thing that gives TensorFlow edge over other competitors is the fact that it is open source and has a huge community support that not only provides researchers a way to build new models, but also a platform to interact with others that face some issues. Now, if we talk about a simple program in TensorFlow, so any program basically consists of a construction phase and then an execution phase. The construction phase is where you build a graph, and execution phase is where you need to evaluate the graph and then create a session, then initialize all the variables. So as you can see here in the example of geometric sequencing, it is so easy to execute. And if this is also hard for you, TensorFlow 2.0, the latest release, makes this even easier to code. It has eager execution by default, which makes things so much simpler and easier. So as you can see, with eager execution, our program has just shrunk to a few lines of code. So guys, that's it for this session. I hope you got to know TensorFlow, what exactly it is and how useful it is. Go ahead and create your own deep learning models and see for yourself what an incredible framework this is. Till then, thank you and happy learning.